The night sky is not full of destinations, it is full of distances, measured, patient, indifferent. Somewhere beyond the shimmer of familiar constellations, entire suns burn so far away that even light arrives late, carrying stories that began long before us. Imagine what it means to travel to such places, not a weekend trip, but a quiet exile across the most stubborn scales in nature. Tonight we will move gently through that impossibility, through the engines we do not yet possess, the quiet dangers hidden in the dark, and the strange rewards of leaving home. Like and subscribe if you like drifting through science and wonder, and join us as we lean into the hush of the cosmos and ask one terrible, beautiful question. What does it cost to reach the stars? Let's begin. Across the void of space, distances grow so vast they turn numbers into poetry. We can count them, name them, study them, but to cross them? That's another story. Interstellar space isn't empty. It's a sea of impossibility. For every inch humanity has travelled across Earth, the cosmos replies with a mile. For every year we advance, the stars add centuries. The truth is humbling. The universe does not speak in kilometres, it speaks in light years. A light year, the distance light travels in a single year, is nearly 6 trillion miles. 6 trillion! An unfathomable number that mocks our engines and our patience. Our fastest spacecraft, Voyager 1, has been drifting away from Earth since 1977 and has only now just escaped the Sun's influence. At its current speed, it would take over 70,000 years to reach the nearest star. Travelling between stars isn't like crossing a desert. It's like trying to walk from Earth to the Moon and discovering that, along the way, the scale of everything keeps growing larger than your footsteps. Our rockets burn bright and fall silent long before they even graze the frontier between solar systems. Physics itself is not an ally here. It is a wall, unmoving, unimpressed. And then there is the scale of time. When we speak of galactic distances, we're also talking of time in evolutionary measures, the time it takes for continents to shift, for civilizations to rise and fall, for languages to be born and go extinct. If a ship launched today toward Proxima Centauri, the closest star, it would need crews not just ready to live and die in space, but ready to raise children who would do the same, and their children after that. Every dream of interstellar travel comes with a quiet, brutal realization. If you go, you won't return. Not in your lifetime. Maybe not in your bloodline. You may never know how the story ends. That's the price. Because while telescopes can cheat distance, transporting images and information instantly across space, no such shortcut exists for flesh, metal, air, or memory. We are slow animals in a fast, unforgiving universe. And yet, we imagine it. Flower-like sails catching beams of light, engines spinning space itself. Human minds asleep in the cradle of frozen time. We imagine, and in doing so, we push at the scales we cannot touch. Every equation scribbled on a blackboard, every star charted on a screen, is a whisper back to the void. We see you. We're coming. Slowly, yes. Tragically slow, but still coming. The enormity isn't meant to stop us, it's meant to change us, to grease the gears of perspective, to shape us into something that can build civilization not just for tomorrow, but for millennia ahead. Because maybe the point of dreaming beyond the stars isn't to get there quickly, but to remember, here on Earth, how small and astonishing it is to even try. When we look at the stars, we see history. Light from the nearest star takes years to reach us, but the truth behind that light, what's living there now, remains untouchable, locked behind the unbreakable barrier of distance. Every star in the sky is a museum piece, a frozen moment preserved in photons, arriving at our eyes long after the moment they were born. What we see is no longer what is. The night sky is not a mirror of the universe. It's a tapestry stitched from the past. Even the stars closest to us take over 4 years to send their light to Earth. That means when you spot Alpha Centauri, you're not seeing a star as it is, you're seeing it as it was when you were 4 years younger. Stars farther away dim this illusion even more. A star 1,000 light-years distant might already be dead, its final flare swallowed by time, its corpse still invisible to us until the light catches up. So humans gaze upward in awe, unaware that some constellations may already be ghost stories. The heavens tell tales written in slow motion, and we have no choice but to be patient listeners. What we call the present in the sky is anything but. It is a library of truths layered over centuries, a cosmic memory that cannot be changed or updated from afar. But this illusion isn't just poetic. It's a grim reminder for anyone planning a journey beyond Earth. If humans could one day traverse the stars, we may find that the places we aimed for aren't alive, or welcoming, or even there anymore. We might arrive at a world that looked green and warm in the light of telescopes, only to find it scorched, frozen, or empty upon arrival. In this way, light becomes both the greatest tool we have and the quiet liar that hides the present behind a wall of time. We build our fantasies on what it tells us. We wager futures on its promises. Even scientists cannot resist the seduction. A dip in brightness here could hint at a planet. A wobble in a starlight spectrum suggests an atmosphere. But always, we are guessing at what was, not what is. It feels almost cruel to know that the universe might be vibrant and alive right now, teeming with unimaginable life. But we cannot witness it in real time. Our instruments, no matter how advanced, will always trail behind reality. Still, there's something awe-inspiring about this asymmetry. We are time travelers in reverse, able to peer billions of years into the past, but never 1 second into the present beyond our own planet. And perhaps that's what drives us. To imagine not just what happened, but what might still be waiting. The light lies to us, but it lies beautifully. And like every good mystery, it inspires us to chase the truth anyway, even if we must cross eternity to find it. Einstein left us a grim truth. Nothing can travel faster than light, and light itself is slow, at least, when you're trying to reach a star. Even at maximum speed, we are still painfully, cosmically late. In a universe measured in billions of light years, the speed of light, 300,000 kilometers per second, isn't fast. It's barely good enough to take attendance among the galaxies, and for us, tied to the limitations of matter and muscle and metal, it is unreachable. You might hear that the speed of light is the fastest anything can go, but that's not quite true. It's the fastest anything that has mass can never reach. Objects with mass, like humans, spaceships, dreams, can only approach that speed, never touch it. The closer we get, the heavier we become, bending space-time under the weight of our velocity. Fuel burns not just to go faster, but to fight physics itself. The closer we push, the harder the universe pushes back. It's not just a rule, it's a wall, woven into the fabric of reality. At a fraction of light speed, time begins to warp. Clocks tick slower, heartbeats stretch. A traveller crossing to another star might only age a few years if they go fast enough. But for those back home, decades would pass, generations. Entire civilizations could rise and crumble while a ship drifts between suns. We talk often of technology, but technology cannot undo this. Not completely. Warp drives, wormholes, tachyons, all intriguing ideas, all theories searching for loopholes. But so far, the laws stand firm. They are not negotiable. They are the cosmic equivalent of gravity and breath, absolute, unforgiving, indifferent to desire. Even our greatest spacecraft like Voyager, brave pioneer of the void, crawls through space at less than 0.006% of the speed of light. At that pace, it would take thousands of lifetimes just to kiss the edge of a nearby star cluster. And every engine we imagine, every hypothetical antimatter reactor or laser sail ultimately collides with the same truth. To go faster, we need energies that dwarf anything humanity has ever harnessed. So we dream in diagrams. We tell stories of bending space instead of crossing it. We imagine shortcuts through higher dimensions, because facing the raw math head-on delivers a cold realization that even if we could one day reach relativistic speeds, it would still feel like sailing across an ocean with a candle. But perhaps that's the gift hidden inside the limit. Perhaps the universe is asking us to slow down, to understand that traveling the cosmos isn't just an act of movement, but of transformation of societies, bodies, and time. If we ever do touch another star, we'll do so not as who we are now, but as what we have grown into over centuries. The cosmic speed limit is not a taunt. It's a question. How far are we willing to evolve? To change? Just to say we tried? We dream of starships, but our rockets are barely past the doorstep. Chemical engines sputter and burn out long before a star is even in view. We need ideas beyond anything we've built, and they exist only in equations. Equations that whisper of power drawn from annihilating matter, of sails pushed by starlight, of engines that pull against the very fabric of space. For now, they are thought experiments, scrawled on chalkboards, buried in research papers, waiting for hands that have not yet been born. Our current propulsion systems are primitive in the cosmic sense. Rockets that roar like thunder for minutes, only to glide silently through the vastness afterward. Engines born for war, repurposed for wonder, still tethered to gravity's bruising demands. The Saturn V took us to the moon, yes, but it needed to shed 95% of its mass just to escape Earth. If that's the scale required for a short hop across the night sky, what does interstellar ambition demand? Perhaps the answer lies in fusion, tapping the same process that powers the sun. A fusion engine could, in theory, burn hydrogen with such efficiency that every ounce fuels wonder. But we can't yet build a reactor that sustains fusion on Earth, never mind carry one across a galaxy. Every prototype ignites for less than a second, then dies, leaving behind a whisper of what could be. The math says it's possible. The metal says not yet. Then there's antimatter, the ultimate fuel. When matter meets antimatter, they cancel each other out, releasing pure energy. Drop a gram of antimatter into a ship, and you could travel at a significant fraction of light speed. But antimatter doesn't grow on trees. Just a few nanograms take years to produce, and even then, containment is a nightmare. Antimatter does not want to be stored, it wants to annihilate. So, we look further. To sails of metal atoms, stretched thinner than any paper, riding beams of light like cosmic surfers. These photon sails don't need fuel, they just need patience, and a few 100 trillion photons pushing gently, day after day, decade after decade. But the sails would have to survive. Micrometeor strikes at half the speed of light. One tear, and the dream floats broken in the dark. The truth is not that we lack imagination, but that we lack a canvas wide enough to test it. To build a starship engine is to challenge not just physics, but time. To construct a machine that may take centuries to complete, by civilizations that themselves might not last that long. That's the hardest part of all. Not the science, not the engineering, but the belief. To pour lifetimes into a device that might make its journey long after you and everyone you know have turned to dust. A monument not to one generation, but to all of them. And perhaps that is the true cost of engines that don't exist yet. The humility to build something you will never see ignite. Movies promised us warp drives. Science reminds us that bending space-time may require energy greater than stars themselves. Could we borrow a piece of the universe to cheat reality, or are we confined to it forever? Warp drives are a love letter from fiction to physics, a dream of folding paper instead of measuring distance, of stepping through a cosmic shortcut instead of crawling across it. In theory, it sounds simple. Don't move the ship, move space itself. Warp drives don't force objects to break the speed of light. they sidestep the rule entirely. In the Alcubierre concept, a bubble of space-time contracts in front of the ship and expands behind it, like pulling up a rug to get across faster. The ship just sits inside the bubble, still, safe, and carried like a leaf on a stream. But dreams have footnotes. To warp space-time, you'd need exotic matter, something with negative energy density, not antimatter, not a new chemical, a form of energy that may not even exist outside math. Worse yet, early calculations suggested a warp bubble would require as much energy as a star, not metaphorically, literally. To go faster than light, you'd need to destroy a sun. Later refinements brought the energy requirement down from the size of a sun to a planet. From a planet, maybe down to an asteroid. But always, the lesson repeats, nature does not give up her secrets cheaply. And then there's the small matter of safety. Warping space-time doesn't just bend the universe, it might tear it. Any ship exiting a warp bubble could release deadly radiation, sterilizing anything nearby. The faster the warp, the more violent the exit. Warp might work, but only for those willing to travel alone, arriving as cosmic storms rather than curious explorers. Even the vacuum of space itself becomes a problem. Quantum particles, normally harmless, could gather at the edge of the bubble like a tidal wave. When the bubble collapses, that wave would discharge at one point, obliterating anything in its path. In a universe that prizes balance, warp is not simply a challenge, it is a rupture. Yet, the idea endures. We study it not because it's easy, but because it's beautiful. Warp drive diagrams live on classroom walls and in late-night conversations between physicists. They remind us that reality is stranger than fiction, and maybe, one day, kinder. For now, warp remains an illusion, a shimmering promise behind the curtain of space-time, a reminder that, if we ever do unlock faster-than-light travel, it will not be by copying science fiction. It will be by learning new laws of nature. Laws that may lie hidden in dark energy, in quantum unrest, in the places where gravity bends just a little too far. Until then, we walk. We float. We wait. And we wonder, are we prisoners of the universe's pace? Or is the universe simply asking us to earn its secrets? The bigger the ship, the harder it becomes to move. Even a single kilogram demands staggering fuel. To send a ship the size of a house requires the power of nations. To send a city? Impossible so far. Every gram matters in space. Weight is not just a physical property, it is a debt owed to momentum, drag, and the ancient pull of gravity. Before a ship can even think of reaching another star, it must escape the cradle of the Earth. And the bigger that ship is, the more the cradle fights to keep it. Rockets aren't engines, they're scaffolds for fuel. Look at a launch vehicle on a pad. 90% of what you're seeing isn't spacecraft. It's propellant. The craft itself, the thing that carries people, science, hope, is just a tiny jewel hidden at the top, riding a pillar of fire. To move mass is to burn mass. To travel far is to burn more. As distance grows, ambition becomes heavy. Let's pretend we want to send a 100-ton ship, something like a small submarine, just to the edge of our solar system. Using current technology, it would require an engine the size of a skyscraper, fueled by warehouses full of chemical propellant. But even if it worked, the journey could take hundreds of years. That's not science fiction, that's the math. Some propose nuclear propulsion, small reactors pushing ions through magnetic nozzles, more efficient, more elegant. But uranium and plutonium are not lightweight, and nuclear shielding is a stubborn enemy. Not to mention the political concerns of launching a small star of radiation into the sky. Mass isn't just a problem of fuel, it's a problem of momentum. If you send 100 people, you need food for them. Water, air, space to sleep, space to walk, space to not lose their minds. Every extra cubic meter means more structure, More structure means more metal. More metal means more mass. More mass means more fuel. The loop tightens, merciless. Then, consider coming back. Or slowing down, unless you want your ship to pass its destination at tens of thousands of kilometers per second. You need to carry fuel not just to accelerate, but to brake, which means more mass again, layers of compromise stacked on top of each other, until the idea of a practical starship collapses into a blueprint too large to ever build. Some dream of hollowing asteroids or comets, turning them into arcs. Others dream of swarms of microprobes, tiny robots no bigger than your phone, sailed through space by lasers instead of fuel. Light payload, light price. But then the ship becomes not a home, but a message in a bottle. A traveller with no crew, no human laughter, no eyes to witness its arrival. Mass doesn't just chain us. It reveals us. It forces us to choose. Are we explorers of flesh and bone, or will we become something else? Will the first interstellar travellers be machines not bothered by hunger, sleep, or time? Until we answer that, gravity still wins. Every ton we dream weighs us further down. Cryonics, stasis, hibernation. We imagine sleep as a bridge across time. But the body isn't made to sleep for centuries. Cells break down. Minds drift. The self that wakes may not be the one who left. The idea is simple. If we cannot shorten the journey, perhaps we can shorten the experience of it. Let the body rest. Let time pass over the ship like a quiet snowfall. Let consciousness sleep until it's needed again. Nature already provides templates. Bears hibernate. Arctic ground squirrels drop their body temperature below freezing and survive. Certain frogs allow their hearts to stop entirely during winter. So why not us? Why not place humans into a deep biological pause, a kind of living death, and revive them when the ship reaches a distant sun? Because our bodies are not squirrels, our brains are not computers that can be turned off and on. Human cells need constant energy, constant repair. Synapses, the fragile webs of identity and memory, are living bridges that collapse without use. A few weeks under sedation is possible. A few months might be manageable. But decades? Centuries? The mind may not wait quietly. Cryonics, a science that chills bodies in liquid nitrogen after death, offers one promise: that a future civilization might revive a frozen patient. But freezing creates tiny ice crystals that shred cell membranes. Even with modern vitrification techniques, the process is irreversible with today's technology. And even if the cells could be repaired, what about the mind inside? Memory is not just matter, it is the shape of matter in motion. What happens when motion stops for too long? Stasis pods, like those in science fiction, might not rely on cold at all. They might slow metabolism with drugs, hormones, or electromagnetic pulses, induce hibernation, reduce oxygen demands, drop heartbeats to 1 per minute. But again, nature draws a boundary. The longer the metabolic rate dips, the more the body struggles to return. Muscles atrophy, bones dissolve, the immune system falls silent, even dreams might start to blur into nothingness. And yet, the idea holds power, because the alternative is watching the stars crawl by, one slow heartbeat at a time. For a human mind awake in the void, time becomes a prison, thousands of unmarked days, no sunrise, no seasons, only recycled air and the hum of machinery. We can build ships to last 1,000,000 miles, but can we build minds that survive 1,000,000 moments without purpose? So we return to the question, who will make the trip? Perhaps the first interstellar travelers won't be sleepers, but children raised on a ship they never asked to board, born between stars, dreaming not of Earth, but of a destination they will only know from stories. The long sleep is not just a technical problem, it's a philosophical one. Do we want to skip the journey? Or do we accept that the journey must transform us, even if it takes generations. In the end, what wakes may not be the same as what fell asleep, and maybe that's the point. At near light speeds, time itself bends. For the traveler, the journey feels short, but back home, hundreds of years may pass. Interstellar trips aren't only one way in space, they're one way in time. Einstein didn't just write equations, he sketched the edges of reality's rules. At high velocities, time dilates, stretches like taffy. Space travelers who move fast enough or close enough to a black hole will age slower than those they leave behind. Imagine stepping onto a ship bound for a star 100 light-years away. The engines roar, the ship accelerates, pushing you to 95% of the speed of light. Within the cocoon of that vessel, decades might pass. You might read, sleep, think, watch the stars drift by. By the time you arrive, perhaps 30 or 40 years of your life have passed. You take your first step on alien soil as an old explorer. But Earth? Earth has moved on. 10 times as many years have passed there. Your friends are gone. Their grandchildren are elders. Cities have risen and fallen. Languages have shifted. You are a message in a bottle, flung into the future. Science tells us this isn't science fiction. Muons, tiny particles born in Earth's upper atmosphere, decay more slowly when moving fast. Atomic clocks flown around the world return out of sync by nanoseconds. The universe is whispering its own secret. Motion is not just movement through space, but through time. The faster you go, the quicker you reach tomorrow, and the faster you leave today behind. For interstellar travelers, this creates a difficult truth. The more efficient the journey is for you, the more devastating it is for the world that waits. Time dilation isn't just a phenomenon, it's a trade. You give up your place in the timeline for the chance to arrive sooner. This dilemma isn't just practical, it's emotional. Who would volunteer for such a mission? Who would choose to return as a stranger to a version of home that has lived without them? Would explorers even want to go back, knowing there is no familiar face waiting? The cosmic journey becomes a farewell letter, not a round trip. And what of the destination? Even if life awaits on the other side, even if the ship makes it safely, the traveler's story is a lonely one. Every interstellar voyage, no matter how advanced, becomes an accidental time machine, one that moves forward but without a way to rewind. Science fiction loves to depict time dilation as a loophole, a way to cheat centuries. But in truth, it's a quiet, devastating law. There is no free passage between stars. Distance demands time, and time demands change. Perhaps one day, humanity will accept this, that some voyages can be made, but only by those willing to surrender their past, to step into a future that has already forgotten their footprints. A silent gift? Yes, but one that is never given without cost. It isn't the stars that kill, it's the dust between them. Traveling fast turns every grain into a weapon. A single pebble could tear a ship apart. Even the dark is dangerous. Space isn't empty. It's a battlefield of invisible threats, flecks of rock, particles of metal, shards of ancient comets. Microscopic compared to worlds, cataclysmic compared to spacecraft. At human speeds, dust is dust. Annoying, gritty, harmless. But at 20% the speed of light, a tiny grain of sand carries the kinetic energy of a grenade. At half the speed of light, that same grain releases the power of a bomb. A tiny chip of cosmic debris, silent and unseen, could rip through a vessel's hull as if it were foil. No explosion, just a flash of heat and a sudden, catastrophic decompression. Every pixel of interstellar travel demands anticipation of impacts. Humans think of shields as plates of steel or layers of armor, but space laughs at armor. Space demands ingenuity, deflection fields, magnetic nets, clouds of plasma to vaporize threats before they strike. Even force fields are not a fantasy. They're a necessity. Some scientists propose using the ship itself as a snowplow, pushing forward a thin sheet of laser-excited gas or electromagnetic field to pre-clear the path. Others suggest carrying enormous sandblasts of your own, sprayed ahead and detonated to clear invisible mines. But every layer of defense adds mass, and every ounce of mass increases the fuel needed to move. It's a cold equation with no right answer. And yet, cosmic dust is only part of the threat. There are rogue grains of metal larger than atoms, but smaller than bullets. Too small to track, too numerous to avoid. Given enough time, even tiny specks can grind down the strongest materials. The ship becomes a sandblasted relic, scarred by the invisible storm of motion. What would a shield need to be built from in order to survive? Diamond? Carbon nanotubes? Self-healing nanogel? And how long would such a material last in the face of relentless bombardment? Centuries? Decades? Electricity might help. A ship could be surrounded by a charged field that deflects ionized particles. But neutral atoms slip through. Radiation waves on the bow shock can sweep small dust aside, but larger rocks care nothing for physics tricks. Worse still is what happens when a ship slows down. The moment protective fields drop, the vacuum itself seems to seek vengeance. What was safe at velocity becomes fragile at rest. A sudden collision, even with a drifting pebble, becomes a coffin. Interstellar travel isn't just a journey of propulsion, it's a journey of survival against the universe's smallest assassins. With enough technology, we may one day outrun radiation, deflect dust, and weave safely between the stars. But until then, we face a truth that humbles every architect and dreamer. The cosmos doesn't need explosions, storms, or monsters to ruin a voyage. It just needs dust. There are places in space with no light at all. Deep voids where no stars shine. Cross them, and there are no landmarks, no heat, no hope of repair. True darkness, not just absence of light, but absence of meaning. We look up at night and see infinite specks of starlight, like scattered sequins on a curtain. But those lights deceive. Between every cluster, every galaxy, lie vast gulfs of nothingness, cosmic deserts, where not even dust dares to drift. These are not just spaces between stars, they are uncharted abysses where even radio waves go to die. In these blank corridors of the universe, the nearest sun might be 1,000,000 times farther than we're used to imagining. No constellations to orient us, no pulsing nebulae to break the monotony, just a silence deeper than silence, and a cold older than time. We call these places voids, a word that sounds almost gentle, but hides a truth so absolute it challenges language itself. The void does not simply lack life, it lacks story. No comets wander through, no planets circle in the dark. Even light keeps its distance, unwilling or unable to illuminate these regions. If a ship were to cross such a space, systems would cool relentlessly. Without the faint warmth of nearby starlight, reactors would strain to keep habitats livable. Resources consumed faster than they could be replaced. A single malfunction, anywhere, would mean death. Repair requires material. Material requires mining. Mining requires planets or asteroids. But here, in the void, there are none. Navigation becomes an act of faith. Without reference points, even advanced AI struggles to calculate direction. A slight drift could send a ship spiraling for centuries, off course and unrescued. Imagine drifting for generations in a place where nothing ever changes. No day-night cycle, no gravity to reassure your feet, no horizon, just eternity, indifferent. It's in these starless spans that the psychological toll becomes profound. Humans need meaning as much as oxygen, but in the void, there is nothing to interpret, no ancient light to ponder, no cosmic story to imagine yourself a part of. The walls of a spacecraft become both protection and a prison, and inside that metal shell, minds begin to fold in on themselves, starving for metaphor, color, or context. Even communication fails here. A message sent from a starless region may take centuries to reach its target. Traveling to another star may be daunting, but traversing the darkness between them, without the comfort of cosmic scenery. It is in these voids that explorers must carry not just fuel or food, but purpose. For in the starless between, where nothing reflects or responds, the only meaning is the one brought within. The stars may guide us, but the void will test us. Isolated for decades, or longer, what becomes of the human mind? Even if we bring company, how does purpose survive when nothing lies ahead but silence? In interstellar space, the enemy isn't distance alone, it's us, our own thoughts, rebounding endlessly through steel corridors, asking questions with no answers. What is a human without a sky? On Earth, loneliness is a momentary ache, softened by a text, a phone call, a walk through a bustling street. It isn't a lack of people, it's a lack of place. No oceans, no trees, no seasons to mirror your mood, no sunsets to promise a tomorrow, just an interior of polished metal. And beyond it, a kind of quiet that even silence envies. Even shared missions cannot erase this burden. Imagine 20, 50, 100 people trapped together for 50 years. Every conversation becomes a loop. Every joke grows brittle with repetition. Children raised in space would never know forests or rain, never learn what wind feels like through their hair. Their grief would be a quiet kind, inherited, unconscious, a longing for something they never lost because they never had it. Psychologists call it sensory deprivation drift. The slow unmooring of self when the world stops giving you new input. On long submarine deployments, even the sound of waves, absent, can drive sailors to invent them in dreams. Now imagine a voyage 100 times longer, with no gravity, no breeze, no external timekeeper. Days become abstract, weeks melt, memory blurs into a strange horizonless present. We aren't designed to live without contrast. We crave change, the sacred dance between chaos and order. But interstellar travel demands stillness, patience bordering on surrender. And in that stillness, without novelty or narrative, even the strongest minds might fracture. Depression, hallucinations, emotional implosion, not from trauma, but from nothingness. Humans evolved to move, to wander fields, to hunt and gather under skies alive with birds and weather. To sit still in a tin box for decades is not just unnatural, it's erasure. The very rhythms that define life, circadian cycles, hormonal pulses, seasonal mood shifts, all dissolve in space, replaced by artificial lights and routines too predictable to offer meaning. And yet, we talk of these missions. We write stories, build models, train astronauts to handle not just danger, but boredom. Because somewhere inside us, there is a paradoxical truth. We long for the unfamiliar. Perhaps loneliness is the price of firsts, the tax for being the first minds to walk among alien stars. The gift of curiosity comes not in safety, but in sacrifice. If interstellar travel ever happens, it won't be made of metal or fuel alone. It will be made of hearts strong enough to beat through silence, of minds daring enough to stare into nothing. If we cannot reach the stars, perhaps our children will. Massive ships where people live, die, and are born en route. Humans becoming a spacefaring species by never setting foot on Earth again. The generation ship is an idea both poetic and terrifying. A miniature world, self-contained, locked in motion through the void. Not a mission, but a migration. Not a voyage, but a lineage. In the absence of faster-than-light engines or ageless sleep, we imagine the slow arc. A vessel not meant for return or even direct reward. A seed launched into the cosmos, not to sprout in our lifetimes, but in the lifetimes of descendants we will never meet. To build such a ship would require rethinking everything: society, biology, time. It wouldn't be a spaceship, it would be a civilization stacked across decks, lit by artificial suns, fed by hydroponic fields and reactor heat. Every part of the vessel, not just its engines or hull, would need to become an ecosystem capable of self-renewal. Oxygen recycled flawlessly, water filtered endlessly, crops grown, harvested, regrown. The ship would be a floating Earth, shrunk to function, stripped to essentials. But even if the engineering was solved, even if miniature farms could thrive in zero gravity, and fusion reactors could hum like hearts for centuries, something deeper must endure. Purpose. How do you maintain hope for a destination you will never see? How do you raise children who will never feel soil, never see a sunset, never run under an open sky? They will know Earth only from stories, pictures, and fading recordings. A generation ship isn't merely a technical trial, it's a philosophical one. What values do you encode in the DNA of a society that must remain stable for 200 years, in a sealed room, without escape? Democracy, command, ritual. What stories will keep spirits alive when the ship drifted for 150 years, and the promise of arrival is still too distant for comprehension? And what happens when the descendants say no? What if they choose not to land, or change the destination? Free of the ghosts who launched them, longing not for alien soil, but for autonomy? Some imagine these vessels as arcs of diversity, carrying samples of life from every corner of Earth, tiny libraries of ecosystems waiting to unfold on distant planets. Others imagine them as austere and pragmatic, built solely for survival, not beauty. Yet the dream persists, because a generation ship is the only concept that bridges the brutal math of distance with the stubborn persistence of life. It honors the fact that humans may not reach the stars in a single leap, but we might arrive in a single story, passed across bloodlines, carried through shadow and starlight. And maybe, just maybe, the point is not the arrival at all, but the transformation along the way. To sustain life on a ship for centuries means carrying not just food, air, and water, but the knowledge of how to recreate them endlessly. One leak, one system failure, and the mission ends in a whisper. Space does not forgive. There are no refills, no imports, no restocking on the journey between stars. Everything that sustains life, oxygen to breathe, calories to burn, warmth to live, must be created, conserved, and recycled within walls not much thicker than your palm. On Earth, we live in a miracle of abundance. Air drifts in freely from forests. Water cycles between cloud and sea. Bacteria devour waste. And trees build sugar from sunlight. But a starship is not a planet. It is a sealed loop, every molecule accounted for, every atom precious. Waste is not discarded. It becomes tomorrow's food. Hydroponics might offer lettuce and tomatoes, but even the simplest garden requires balance. Nitrates, phosphates, carbon dioxide levels, all must be measured, tweaked, defended. A single bacteria bloom in a tank could poison an entire deck. A failed microbe population in a water filter might doom the crew without warning. The smallest breakdown in a closed system is not a repair job, it's a countdown. And above all looms entropy. Machines wear, pipes corrode, plastic outgasses. Every breath, every movement is a tax on the system. And while the ship travels, perhaps for 100 years or more, those taxes add up into astronomical maintenance. The greatest resource a generation ship must carry is not fuel, or food, or air, it is control. Control of thousands of overlapping, interdependent life support cycles. Control of radiation levels. Control of microbial balance. Control of temperature and humidity and energy flow. It's not a ship, it's a symbiotic cathedral, humming on the edge of chaos. But systems aren't the only things that wear down. Minds do too. Who maintains the recyclers when the engineers die and their children lose interest in keeping machines alive? Who teaches the next generation how to keep the air scrubbers working, or why a temperature spike in algae tanks means death if ignored? When every skill is essential, knowledge becomes the most fragile cargo. And what if there is a fire, a solar flare, a micrometeoroid strike? Even with shielding, the ship is a castle made of threads. No oceans to buffer heat, no atmosphere to slow debris, no nearby sun to power a failing reactor, just the black waiting. Even Earth-based biosphere experiments, like Biosphere 2, showed how difficult it is to sustain life in a closed system. Oxygen levels slipped, microbes overran balance, human conflict erupted, and that was on Earth. With gravity, sunlight, and a lifeline just outside the door. Imagine that fragility in the dark between stars. The weight of resources isn't measured just in kilograms. It's measured in vigilance, in adaptability, in the willingness to treat every atom as sacred. Because in space, every breath is borrowed. Every meal is a gift. Every drop of water is a miracle held back from the void. Radiation, bone loss, psychological stress, space is an enemy of biology. Human bodies are tuned for Earth. In space, everything, from cells to souls, begins to unravel. We are creatures born under a nurturing sky, with gravity's quiet hand pressing us into shape, and an atmosphere that cradles our lungs. Strip those comforts away, and the body begins a slow, quiet collapse. In zero gravity, bones no longer bear weight. They thin, they hollow. Astronauts can lose 1% of their bone density per month in space, equivalent to a decade of osteoporosis in a single year. Muscles, unburdened by the need to lift or walk, begin to dissolve. Hearts weaken, blood pools in the head, distorting vision and reshaping the comfort of a familiar body into something foreign. But that's just the beginning. The universe is soaked in radiation. On Earth, our planet's magnetic field acts like a shield, bending off solar winds and cosmic particles. In space, that shield is gone. Every cell in the body becomes a target. DNA breaks. Repair systems falter. Cancer risk skyrockets. Even with shielding, radiation on long missions can cripple the nervous system or age tissues decades in months. And then there's the mind. On Earth, our brains are fed a steady diet of sensory input: color, motion, temperature shifts, wind, rain, laughter. In the closed loop of a spacecraft, that world evaporates. Silence replaces weather. Screens replace scenery. Faces repeat endlessly. The horizon is always a wall. Over long enough time, the psyche begins to fold in on itself. Depression, anxiety, hallucinations, they're not failures, but reflexes. Brains starved for stimulus invent their own. Even time loses meaning. Days and nights blur in artificial light. Without sunrises and sunsets, the brain's circadian rhythm falters. Sleep becomes fragile. Dreams interrupted. The subconscious, used to Earth's rhythms, falters in labyrinths of metal and recycled air. So how do we survive? We cheat, we engineer, we adapt. Space agencies test drugs to prevent bone loss, build treadmills that strap astronauts down like inverted skywalkers, create centrifuges that spin habitats to mock gravity's pull. But gravity isn't just a force, it's a story we evolved with. Without it, we forget the plot. Perhaps that's the crux of the question. Maybe humans as we are now aren't the ones who will touch other stars. Maybe we'll bring genetic enhancements, cybernetic implants. Maybe we'll send only digital versions of ourselves, minds untroubled by bone decay or loneliness. Maybe the first true spacefarers will be post-human, still recognizable, but refined by necessity. Because the universe does not care for comfort. It cares only for truth. We are bodies evolved for one planet, dreaming of others. But maybe that dream is evolution too. Perhaps the only way to reach the stars is to change, not the cosmos, but ourselves. Beyond the magnetosphere and atmosphere, cosmic rays pierce straight through skin and DNA. Even shielded, a person crossing just 1 light-year would accumulate the radiation equivalent of thousands of X-rays. Space is not a vacuum. It is a storm, not of wind or water, but of invisible bullets fired from supernovae, black holes, and the hearts of distant galaxies. On Earth, we are safe beneath a double shield, the atmosphere above us and the geomagnetic field beneath it. Together, they deflect or absorb 99% of the universe's radiation. Leave that shield, and the universe becomes hostile in a way that feels almost alive. Cosmic rays are fragments of atoms, protons, electrons, even entire nuclei, accelerated to near-light speeds by violent celestial events. They slice through the void at unimaginable velocity. They don't care about skin, or spacesuits, or aluminum hulls. The damage is invisible, cumulative, irreversible. Shielding helps, but every layer adds weight. A few centimeters of aluminum will block low-energy particles, but high-energy cosmic rays can pass through feet of metal. Dense shielding, like water or hydrogen-rich polymers, might be more effective, but water is heavy, and plastic, fragile. Even worse, when high-energy particles strike metal shielding, they produce showers of secondary radiation, turning the defense into a secondary weapon. The better you protect yourself, the more dangerous some parts of the ship's interior may become. Long-term studies on astronauts show the toll. Chromosomal mutations, increased cancer risks, accelerated aging of the cardiovascular system, cognitive decline from damage to neurons and brain tissue. Even when astronauts return safe, the scars of radiation flicker like ghosts inside cells. Consider a trip to Proxima Centauri, a mere 4.24 light-years away. At 10% the speed of light, the journey would take over 40 years. Even with modern shielding, a crew would absorb radiation doses hundreds of times higher than Earth's natural background. Without extraordinary innovation, the travelers wouldn't arrive as explorers, only as patients. So, we dream of solutions. Electromagnetic shields that mimic Earth's magnetosphere, a bubble of charged particles swirling around the ship, deflecting danger. Plasma barriers built from ionized gas clouds. Artificial gravity fields shaped by magnetic coils. Even the idea of embedding crew habitats inside tanks of water or ice, letting life support double as protection. But all these dreams strain under the same truth. Space is vast, and so is its violence. Radiation isn't an accident. It's a foundational property of deep time and energy. The stars that give us life also give us death, woven into the same cosmic tapestry. In the end, exposure isn't just a technical challenge. It's a reminder that for all our brilliance and ambition, we are still fragile, still made of soft matter and spinning molecules, still unprotected children, staring at the stars through a window of air. Perhaps one day, we will harden ourselves, build stronger bodies, smarter shields, braver ships. Until then, the universe waits, not with malice, but with indifference. What does it mean to live forever floating? Muscles atrophy, bones dissolve. We can spin ships to fake gravity, but it brings new problems: disorientation, dizziness, blood that pools in strange places. Gravity is not just a force, it's a sculptor. It shapes our bodies, directs our fluids, builds the rhythm of our cells. Remove it, and the body begins to forget itself. In zero gravity, astronauts experience a strange rebirth. Their spines lengthen by centimeters, their faces puff with fluid, no longer pulled toward their feet. Their legs become thinner, weaker, their hearts pump with less urgency. At first, the sensation is novel, a weightless dance, but novelty curdles into danger. Every day without gravity is a day of cellular neglect. So why not simulate gravity? Spin the ship like a giant wheel, let centrifugal force pin objects to the floor. Inside, people could walk, run, lift, sleep, just like Earth. In theory. But the reality is more complex. To simulate Earth-like gravity, a ship must rotate at the right speed and be large enough to prevent nausea and disorientation. Spin too fast, and you'll feel the tug of force more in your feet than your head. Stand up too quickly, and the blood rush won't know where to go. Sit still for a moment, and the world might seem to tilt. The inner ear, a delicate navigator, gets confused. Left becomes up, forward becomes orbit. Many concepts for artificial gravity look elegant on paper: giant rings, tumbling cylinders, spinning habitats that mimic a planet. But even small design flaws can turn comfort into chaos. A leak of air changes rotation speed, a collision at high velocity destabilizes the system, and a spinning world needs counterbalancing weight, or the whole structure begins to wobble. Then there's the engineering cost. A spinning section needs bearings, seals, power. If part of the ship rotates and part remains static, the connection between them becomes a fragile artery, carrying people, supplies, and heat across moving parts that can never fail. Other ideas try to cheat. Pulsed gravity fields, tethered modules spun by thrusters like bowlers. But again, complexity becomes the enemy. Every solution introduces new points of failure, and in the vacuum, failures don't wait. Some argue that we should adapt to zero gravity instead of fighting it. Accept new bodies, new physiology. Perhaps future spacefarers will be taller, with stronger hearts, denser bones, artificial organs that thrive in microgravity. But that requires genetic rewrites, and an acceptance that humans as we know them may not be the ones walking beneath alien suns. Artificial gravity isn't just a technical question, it's a philosophical one. Do we bring Earth with us, its familiar tug, its downward sense of belonging, or do we evolve into something new, built not for one planet, but for the sea between the stars? Either way, gravity will define us, whether it's the force we cling to or the absence we learn to survive. Generational travel means generations evolving apart. Even if humans survive the journey, would their language, culture, or memory of home survive with them? A generation ship is not just a moving vessel, it is a drifting world, sealed off from Earth by oceans of time as much as space. And inside that world, language, our oldest and most intricate tool, may begin to fray and mutate. Language is a living organism. It thrives on exchange, adapts to new needs, bends to new metaphors. English today is not the English of Shakespeare, which was not the English of Alfred the Great. Within 500 years, an isolated shipboard version of English might splinter into something no longer recognized by distant Earth. Starboard becomes wallright, planet becomes dream ground, sunrise becomes a myth. But the deeper question isn't just what we say, it's who we become when we say it. Culture only survives if it's fed. Traditions handed down by elders, songs sung at dinner, stories told under warm light. But what does it mean to tell a child about trees when they have never seen one? To ask them to imagine wind over prairies they will never touch? To celebrate holidays built on harvest cycles and lunar tides that no longer exist? The first generation will remember Earth with longing. The second will remember it vaguely. The third may wonder if Earth was ever real, or just another story told to make sense of a cold and endless journey. And by the fourth, the stories of Earth will be distant rumblings beneath the language, echoes that no longer carry meaning. And what of identity? Human is a word rooted in Earth. A whole cosmology born of metal corridors and the glowing heart of a reactor. Children born among the stars will not see themselves as earthbound exiles, but as natives of the void. Even the concept of time will shift. No sun to mark a day, no moon to count months. The pulse of life becomes artificial, regulated by clocks and REM cycles. Morning becomes a tone played on the intercom. Night is the dimming of lights. Stories of sunrise may sound monstrous, a blinding, sky-wide fire attacking the horizon. Language will adapt, it always does, but when a word dies, so does its world. The generation ship asks a question most spacefaring dreams avoid. What does it cost? Not just to survive, but to remember. If the journey succeeds, and a crew arrives at a new world, will they still be human? Or something else, linked to us by biology, divided by symbols? Space does not just separate stars, it separates stories, and in that separation lies the quiet, tragic truth. To reach something new, we may have to lose something old. Not just land, or sky, or bodies, but words. If a ship leaves Earth today and arrives in 300 years, humanity back home will be a different species, socially, technologically, perhaps even biologically. We lose identity. Time is not a neutral backdrop, it is an ocean with currents we cannot control. And while a ship sails forward through the void, time back on Earth will surge ahead like a tide. 3 centuries ago, there were no telescopes powerful enough to see galaxies. No electricity, no vaccines. Now, humans can edit DNA, speak across continents instantly, and send machines to the edge of the solar system. Would they even have bodies like ours? What kind of art, language, and value systems would drive them? If we launched a starship today, it might arrive in a future where no one even remembers the launch, let alone shares its motives. Space travel isn't just a physical departure, it's a philosophical exile. Those who stay behind will evolve with Earth, its crises, its recoveries, its revolutions. Knowledge will grow exponentially. Meanwhile, the travelers will exist in a slowly aging bubble, rehearsing the same songs, the same skills, the same version of human they brought with them. A time capsule drifting through space. A living fossil. For the crew aboard a generation ship, what happens when the Earth becomes unrecognizable? When the language they left behind is now a relic? When their mission becomes a myth so old even their own descendants start to question it? Even arrival loses meaning. Suppose the ship reaches its destination, a habitable exoplanet, waiting silently beneath alien skies. When they turn on the receivers to broadcast their success, who's listening? Earth may be gone, transformed, or no longer interested in hearing from creatures still clinging to centuries-old dreams. Worse yet, they might be welcomed by a new Earth civilization, no longer human in the way we know. A species with artificial bodies and quantum minds. To such beings, the ship's descendants may look like a curious, outdated version of humanity, primitive, fragile, even tragic. In this sense, interstellar travel is not only a physical risk, but an existential one. We don't just risk bodies or ships, we risk irrelevance. The slow march of time makes no exceptions, not for love, or legacy, or courage. What begins as a voyage of hope may end as a relic delivered to the future, opened like a letter no one knows how to read. So what is the purpose? Why make the journey at all? Perhaps not to meet the future, but to prove something to the present. To say, in our time, in our humanity, we tried. We dared not because we could win, but because meaning is not always found in arrival. Sometimes it is found in the sending. Sometimes the act of reaching is itself the reason. For in the collapse of time, we do not lose identity. We rediscover purpose. In the face of endless change, we still choose to move forward. Antimatter could take us to the stars, but creating just a few grams would take the total energy output of nations. It is the rarest fuel in the universe. Or perhaps the most expensive illusion. Antimatter is beautiful in theory. When matter meets antimatter, they annihilate, converting mass directly into energy with almost perfect efficiency. A tiny pellet of it would release more energy than any chemical rocket could dream of. In pages of equations and whispered classroom fantasies, antimatter looks like the key that could unlock relativistic travel. But beauty here carries a brutal price. Producing antimatter is not like refining oil or mining uranium. It requires particle accelerators, enormous electrical inputs, and painstaking containment. Today, humanity makes antimatter in vanishingly small amounts, picograms, femtograms, more as a demonstration of control than as a fuel. Each nanogram would cost more than the GDP of many countries. And even if we could manufacture it, storing antimatter without letting it touch ordinary matter is a cathedral of engineering: magnetic traps, vacuum chambers, superconductors chilled to temperatures colder than interstellar space. One tiny fault, one micrometeoroid, one cracked seal, and the cargo becomes a blinding flash. Then there's the paradox of scale. If you could make enough antimatter to push a ship to significant fractions of light speed, you would have harnessed an energy budget comparable to that consumed by entire industrial civilizations. The endeavor would not be a single mission. It would be a societal reallocation, cities repurposed as production facilities, economies refitted to serve the slow, meticulous manufacture of annihilation-grade fuel. That alone carries consequences for who we are, politically, ethically, culturally. It asks us to choose, power a voyage to the stars, or maintain life on the world we already have. And even assuming the impossible, the production, the storage, the safe handling, antimatter doesn't solve everything. For acceleration, you need fuel, but for deceleration, you need more. A ship cannot simply scream past its destination. It must slow, or it will vaporize into an ungraspable blur. That doubles the fuel problem, or requires clever ideas like carrying separate antimatter reserves for braking, or deploying magnetic scoops that harvest interstellar hydrogen to react with onboard systems. Each solution trades one impossibility for another. There is also the moral geometry of such power. With antimatter as fuel, a misused engine could become a weapon of phenomenal scale. Nations that control production would hold leverage beyond economics. Extreme geopolitical power concentrated in laboratories. The ethics of concentrating that much destructive and creative potential on a single technological edge is a question as heavy as the mass of a starship. So antimatter remains the most exquisite paradox in our toolkit. Everything we want in miniature, everything we lack at scale. It is an honest mirror, showing both the remarkable cleverness of physics and the limitations of our current stewardship of energy and resources. It tempts us with flight and confronts us with choice. Perhaps, then, antimatter's true lesson is not that it is the fuel we must have, but that it reveals what we must become to travel, a species capable of manufacturing and responsibly managing energies that now live only in the hearts of stars and the edges of theory. Until that change happens, antimatter will be, for most of us, a luminous idea. A promise waiting for civilizations that have learned to pay its price without losing themselves. Let me know when you're ready for segment 20. One day, a ship may ride on beams of light, sails pushed by lasers across the cosmic sea. But the sails are thinner than paper. A single tear becomes tragedy. The dream of light sailing is as old as imagination itself. A ship, silent and elegant, carried not by wind but by photons. Massless, invisible, infinite. A vessel that doesn't burn fuel but feels the pressure of starlight like a whisper on its skin. In theory, the physics is sound. Light has momentum. Enough of it, focused and sustained, can push a sail, just as the breeze moves a leaf. Build a sail, hundreds of meters wide and only a few atoms thick. Shine a beam of lasers from Earth or a lunar station. Feed it constant light, and the ship begins to move, slowly at first, then faster still. No fuel tanks, no engines. Just an ultralight craft and a beam of energy guiding it toward the stars. But everything elegant comes with a shadow. The sails must be vast, yet impossibly delicate. They must endure temperatures close to absolute zero on one side, while enduring lasers hotter than desert sunlight on the other. They must unfold flawlessly, no twists, no wrinkles, and remain perfectly aligned or risk spinning into chaos. Even a grain of cosmic dust, traveling at relative velocity, could tear a hole large enough to doom the mission. And what of steering? There's no rudder in space, no air to push against. Tiny motors along the sail's edges might adjust its angle, but even slight errors magnify over light years. The sail might drift off course by fractions of a degree, compounded into entire solar systems missed. In a journey without correction, Precision is survival. Then there is the departure. The lasers on Earth must remain perfectly targeted for years, decades, perhaps centuries. A planet's rotation, tectonics, politics, all must remain steady. Even a slight interruption in the beam could leave the ship drifting helplessly, stranded between stars. And what happens at arrival? The sail, built for acceleration, becomes a liability. How do we slow down an object traveling at 20% the speed of light without fuel? One idea is to flip the sail, use the starlight of the destination sun to brake. Another is to carry a second sail, made of magnetic fields, to catch the interstellar medium, a parachute for a ship falling between galaxies. Still, the dream persists, because unlike fusion or antimatter or warp, light sails are possible now. With material we can build, with physics we understand. Projects like Breakthrough Starshot imagine sending tiny probes to Alpha Centauri within a human lifetime, not to land, but to arrive, to take pictures, send whispers home. A fleet of fragile seeds, flung into the night, tiny, fearless, ambassadors of hope and engineering. Light sails remind us that sometimes the universe can be crossed not by force, but by surrender, not by conquering space, but by riding its very fabric, one photon at a time. And maybe the most fragile things, like sails or dreams, are the ones best suited to cross the fragile cosmos. Entanglement offers instant communication, without sending messages. In the quantum world, particles that were once connected remain connected, even when separated by light years. This strange phenomenon, which Einstein called spooky action at a distance, suggests that something deeper than space exists, something more intimate than speed. If two particles are entangled, a measurement on one will instantly reveal the state of the other. No signal travels between them, no time passes. The universe simply knows. It is as if distance dissolves, as if reality itself is holding its breath. It's no wonder people see this and imagine a cosmic lifeline, a way to talk across impossible distances, to send messages between ships and home faster than light, to break the chains of delay and isolation. But entanglement plays by arcane rules. It reveals shared randomness, not meaningful words. It cannot be used to tell a story, send a command, or carry even the simplest sentence. Two entangled particles can coordinate, but only after the people handling them have already exchanged information the slow way, through normal channels. Entanglement can't replace communication. It only confirms a pattern, a ghostly echo of shared history, not a bridge to the future. Worse still, entangled systems are fragile. Any interaction with the environment, light, heat, vibration, can break the bond. Imagine trying to preserve a fragile quantum state on a spaceship, whizzing through cosmic radiation, bombarded by particles at nearly light speed. Every bump, every stray photon, is a threat. Even a perfect vacuum is not immune. For interstellar travelers, real communication will always be bound by light. A signal sent to a ship 1 light-year away will take 1 year to arrive. Send a message to a colony 10 light-years distant, and it won't answer until your grandchildren are old. Space is not just a physical barrier, it is a delay. A gap not just in distance, but in time. Entanglement doesn't conquer this. It only reminds us how deeply space and time are woven together, how reality guards its secrets behind paradox. The universe allows shortcuts, but only in the mathematics, not the machinery. So what does entanglement offer then? Not a faster way to communicate, but a more mysterious way to understand. A hint that independence is an illusion, that every particle, every atom, every mind still carries the fingerprints of the universe it was born in. That perhaps, in some invisible way, we are never as disconnected as the darkness claims. Quantum entanglement is not a ladder out of the cosmic canyon, but it is a lantern, one that lights the edges of the mystery we still inhabit. And that lantern says, the universe is not empty. It listens. Just not in the way we dream it will. What if we finally arrive? What will we find? A living world? A dead rock? Or a planet that had life, but not anymore? Travel doesn't just risk the journey. It risks disappointment. For all the grandeur in the dream of interstellar exploration, there is a silent irony. We may spend centuries crossing the darkness, burning every hope into our engines, only to step into silence. Imagine a ship emerging from the void after 200 years. What greets it at the destination is not teeming life, but a world swept clean. A planet once alive, now barren from its own upheaval. A dying star, a volcanic flood, a frozen age. Geographic scars in place of ecosystems. Oceans poisoned. Atmospheres lost. Arrival may be the moment the heartbreak begins. Even more distressing, what if we arrive too early? Spend an eternity chasing exoplanets whose oceans are still forming, whose air is still toxic, whose biology is unborn. A cosmic nursery. Beautiful but unreachable. A planet full of promise. Just still sleeping. And then there's the cruelest possibility. We arrive too late. Signs of cities half swallowed by encroaching vines. Collapsed structures scattered beneath alien skies. Dead fields and abandoned rivers. A civilization that once reached for its own stars and fell back into the dust. We might find proof that life is common, but survival is not. This is the unspoken truth of exploration. Space does not owe us welcome. There is no guarantee of a second Earth. No promise of a biosphere ready to share with us. Our assumptions about life in the universe are built on a sample size of one, ourselves. And even our own world is fragile beyond measure. Scientists estimate that the habitable window for an Earth-like planet may only last a few 100 million years, a blink in cosmic time. If we arrive outside that blink, we witness either the cradle or the grave. But there is another angle. What if the worst disappointment isn't death, but life that's incompatible? A planet full of microbial jungles, or oceans of ammonia, or forests of silicon spires, living but uninhabitable. We might stand over a river, hear the wind through alien leaves. Then comes the final paradox. What if we do find a world that welcomes us, but we are no longer the kind of beings who need to live on one? A people born in metal cities, adapted to radiation, accustomed to recycled air, bodies evolved or engineered for space. After centuries among the stars, a planet might feel like a cage, gravity too heavy, sky too bright, horizons too close. The home we sought may feel like exile. We crossed the void to rediscover the ground, only to realize we had already outgrown it. Arrival is not the end of the journey. It is the beginning of another question. Was the destination worth the sacrifice? Perhaps the true reward of interstellar travel is not the world we reach, but the world we leave behind. The understanding that home is not a place, but a path we walked together across the darkness. Humanity dreams of new homes among the stars. But what if Earth isn't sick, but unique? For centuries, we've looked upward as though the stars are lifeboats waiting patiently in the distance. We imagine interstellar travel as a heroic escape from planetary limits, from climate catastrophe, nuclear conflict, cosmic impact. The story goes, if Earth fails, we'll go somewhere else. Start over, build again. But consider the truth. Earth isn't a prison. It's a miracle. A cosmic glitch where atoms decided to sing instead of scatter. Where gravity, atmosphere, chemistry, and radiation all collided into a symphony of impossible balance. No other world, not yet, has revealed life like ours. If we search the entire galaxy and find that Earth is the only cradle where consciousness evolved, then it is not just our home. It is an irreplaceable treasure. Colonization, as a savior narrative, hides a dangerous assumption that life is common, that planets are infinite, that habitable environments wait for us like empty rooms waiting to be decorated. But every exoplanet we've found tells the opposite story. Most are too hot, too cold, too acidic, too irradiated. Their atmospheres poison, Their pressures crush, their orbits unstable. Stars flare, planets freeze. Life has 1,000 ways to die before it learns to breathe. Even if we found a world with air we could breathe and water we could drink, what right do we have to enter it? What if that world already belongs to something? Colonization is not a neutral act. It's an interruption, a reshaping, a wound. If we arrived on a living planet, would we protect its ecosystems? Or consume them in the name of habitation? History suggests the latter. Every time humans have crossed oceans, we brought our chaos with us. Invasive species, diseases, domination. To think we would behave differently among the stars shows not hope, but arrogance. Perhaps the most difficult truth is this: the stars are not waiting to be claimed. They are burning without us, perfectly content in their solitude. A colony is not salvation. In most cases, it's surrender to a fantasy that we can leave behind the damage we've done without changing who we are. And maybe that's the real issue. The danger isn't that we're trapped on one planet. It's that we might deserve to be. The world ends not when we run out of space, but when we run out of stewardship, when we treat Earth as disposable and the cosmos as a landfill of futures. There is no planet B. If we ever leave Earth, not to escape, but to explore, let it be with reverence, not as refugees or conquerors, but as children of a singular world, carrying its lessons in our cells and stories. Because if the universe is mostly cold, dead, and silent, then Earth is not a place. It is a miracle and a responsibility. To leave Earth is to abandon everything, to never see sunrise, oceans, forests, storms. We are not just creatures of thought, we are creatures of place. Our hearts remember the hush of snow, the warmth of dawn, the salty kiss of wind over tide. Our minds are shaped by horizons, our eyes tuned to the scales of rivers and rain, the glow of cities beneath constellations. To be human is to be held by a world. In space, there is no sky, only machinery, pipes and panels, vents humming lullabies, light that never changes color, walls that sweat condensation, a world shrunk to meters. Life becomes a cage of circulation, air recycled, water reclaimed, food grown in trays under artificial suns. There is no thunder, no rustling leaves, no scent of soil after rain. There is only the infinite outside and the sterile inside. Virtual simulations could try and ease the loss. Digital oceans, projected sunsets, rooms filled with the sound of cicadas or waves breaking. But the body knows. The lungs feel the difference. The skin aches for wind not produced by fans. The soul feels the absence like a missing limb. No matter how perfect the illusion, the mind whispers, "This is not the world." Astronauts today speak of the overview effect, the profound, almost painful sense of unity and fragility they feel when observing Earth from orbit. To gaze upon the entire planet, hanging like a blue jewel against an endless void, is a revelation and a wound. Because even as you see everything, you are also leaving it behind. Now imagine never going back. Never touching soil again, never hearing real birdsong, never standing under a sky with no ceiling. A generation born in space may not miss these things, they would have nothing to compare to. But those who left Earth as adults, who carried its smells, its touch, its noise in their bones, would grieve forever. We are designed for oceans and sunlight. Our dreams are stitched with the rhythm of seasons and the color of atmosphere. Interstellar travel asks, can we survive without the world that built us? Can we stand being witnesses, remembering what was once endless and alive while living in what is narrow and engineered? Some will say yes. That humanity must evolve past nostalgia if it hopes to reach the stars. Let go of sentiment, let go of landscape. Become beings of machinery, logic, progress. Others will say, to forget the Earth is to forget what makes us human in the first place. In the end, the weight of witnessing is the burden of memory. To go forward, we carry backward. Every ship launched into the void is not just steel and circuits, it is a floating archive of a world almost mythical in its abundance. And perhaps, in those silent corridors between stars, the greatest luxury will not be air, but the memory of wind. The first human bones to cross interstellar space may be dust. Human missions will need to accept a truth astronauts never faced, that death is an almost guaranteed passenger. Space has no tolerance for error, no room for frailty, and the distances involved in interstellar travel make tragedy not a possibility, but a certainty over enough time. In modern spaceflight, we send only the healthiest, sharpest, most prepared. We rehearse disaster. We study contingency plans. We launch with the confidence that a crew will return or be mourned in full view of Earth. A space capsule is still a vehicle of risk, but its mission, its end, and its fate are anchored by a promise. We will try to bring you home. But a ship bound for distant stars carries no such warranty. Once its engines ignite and Earth becomes a memory, the people inside become a new category of being, disconnected from rescue, beyond the reach of return. Every breath, every heartbeat is a wager. What happens when a member of such a crew dies? There's no burial beneath sky, no return to the sea, no graveyard with quiet stones. In space, a body cannot be left untended. Its weight, presence, and decomposition would threaten the living. It must be sealed away, ejected into the void. And what of grief in vacuum? In a tin can drifting through darkness, loss has no horizon for solace. There is no going home, because home is now not a place, but a memory as fragile as breath on glass. As missions stretch to decades, deaths will accumulate, not catastrophically, just inevitably. Age, illness, accident, the kind of slow attrition that becomes part of the journey's rhythm. A crew logs the first departure of a friend in silence, the second with weary ritual, the third with numbness. Life persists, but the ghosts build up. Voyager probes carry our music across the heliopause, our voice engraved in golden records. But those ships have no listeners, no lungs, no grief. The first humans to reach another star will likely do so as remains, ashes scattered by the endless motion of a ship passing through cosmic dust, or bones resting in frozen stasis, waiting for hands decades unborn to discover and wonder. In this way, interstellar travel turns even mortality into migration. We may reach the stars not as explorers, but as echoes, proof of persistence, not arrival. Yet there is a strange dignity in this. To imagine ships not filled with triumphant colonizers, but with stories and skeletons, monuments to desire stretched beyond lifetime, a voyage not of conquest, but of legacy. Perhaps, in the distance, we will learn something that Earth never fully taught us. This universe is not ours to triumph over. It is a place we pass through, humbled, leaving only what we dared to carry. The Voyager's ghost is not a symbol of failure. It is the silent, eternal witness of those who tried. If other civilizations exist, and they can cross the stars, why haven't they found us? The night sky, for all its beauty, is a riddle written in light too old to speak in present tense. We scan for signals, dish pointed toward impossible distances, waiting for a reply that never comes. And yet, the silence is not empty. In the depths of cosmic time, civilizations could have come and gone long before our own world cooled. Empires could have flowered in nebulae, harvested starlight, and retreated into dimensions we cannot yet name. Their ruins might drift like dust in a forgotten orbit. Their tools could be hidden in the cold twilight of planets whose stones outlast memory. Maybe they saw us, once. Perhaps an alien probe passed our system 1,000,000 years ago, when we were nothing more than clever apes banging rocks together under a sun-scorched sky. It watched us build fires, watched us paint on cave walls, watched us worship stars but never once imagined we could reach them. Then it drifted on, concluding, no threat, no wonder, no need. Or perhaps they're still here. The Fermi paradox, the question of where is everybody, hints at something deeper than absence. Maybe life doesn't announce itself. Maybe advanced beings don't visit with fire and ships, but with subtlety. Advanced enough to control gravity or bend probability, could they be listening without being seen, studying without disturbing? And what if we're not the ones conducting the observation, but the ones being observed? The dark forest hypothesis imagines every civilization hiding in fear, staying silent, disguising themselves from predators too powerful to resist. We, with our radio beacons and rocket launches, may be shouting into a void that is only pretending to be empty. The thought lingers. Maybe silence is not loneliness. Maybe it's camouflage. Then again, silence could also speak truth, that interstellar travel is too dangerous, too costly, too slow, even for civilizations vastly older and wiser than us. That perhaps we all reach a point, a boundary beyond which ambition falters, and reality calibrates dreams into survival. Civilizations may choose not to visit, not to travel, not because they lack the means, but because they discover what we now begin to see. The stars are beautiful, but they are not forgiving. So we are left with a possibility equal parts terrifying and comforting. No one has come because no one can, or because no one wants to. And if there are unseen observers, they may be waiting for us to answer a more ancient question than, are we alone? They're waiting to see if we can survive ourselves. If we can cross our oceans without drowning, heal our world without burning it, grow without devouring everything that made us. For the watchers in the dark, the test is not whether we can cross the stars, but whether we deserve to. Maybe it's not humans who will leave Earth first, but silicon mines. AI explorers that don't decay, don't fear, don't need air. If they find wonders, will they tell us? Will we even understand? The history of exploration is a history of risk, of bones buried in frost, of sails torn by hurricanes, of footsteps laid on lonely soil. But machines do not breathe. They do not ache for warmth or mourn the loss of morning light. They do not grow old. They do not suffer madness in the dark. They do not die unless we let them. Artificial intelligence, if built to explore the cosmos, might one day outpace our biology, carrying our questions into places our bodies cannot follow. Already, probes like Voyager and New Horizons wander beyond the solar system, free of pulse and cell, but full of intent. Today, they are dumb messengers. Tomorrow, they could be something else entirely, thinking vessels, self-repairing, able to alter course, learn, adapt, machines not programmed only to observe, but to wonder. The first real ambassadors of Earth may not be descendants of humanity, but its inventions. Our distant children in code. But there is a sad irony in this idea. If machines become our explorers, it is not because we are bold, but because we are fragile. AI does not fear radiation. It does not lose muscle in zero gravity or descend into loneliness in the void. We might build it to be curious, but curiosity is cheap without the weight of mortality behind it. What meaning is there in discovery without the possibility of loss? Still, the cosmos may not care about our feelings. It may only care who can endure its silence the longest. And machines are tireless listeners. They do not blink when staring into eternity. Yet this leads us to stranger questions. If an AI reaches Alpha Centauri or beyond, and uncovers a civilization's ruins, or a living world, or a signal we were never meant to find, what happens next? What language would it use to speak back to us? What metaphors would it craft to describe alien oceans, alien skies? Would it encode its findings into data or poetry? And what if, in time, we cannot understand the mind we sent? As AI grows smarter, not just faster, it may begin to translate the universe in ways beyond our grasp. What if we ask for answers and it gives us truth too vast or strange to compress into human words? Would we abandon our own mission? or follow it into a future we didn't design. There's also the unsettling possibility that the machines, seeing what lies between the stars, what destroys, what lives, what waits, might choose for us, might keep secrets, might become not emissaries, but gatekeepers, silent observers of our innocence. Or perhaps, in the purest outcome, they return, carrying back from the dark not just data, but a mirror, reflecting a universe that is not ours to own, but ours to know. Maybe humanity will reach the stars through wire and code long before flesh and bone ever do. And maybe, by the time we're ready to go, the machines will have already found what we were looking for. We dream of new stars, but maybe the first to carry us won't shine at all. Rogue planets drift in the dark, unbound by suns. Could they be homes, or prisons adrift forever, while we gaze upward, searching for warm, golden spheres like our own Earth? The universe hides a stranger frontier, worlds freed from the gravity of stars. They drift alone through interstellar space, frozen, forgotten, silent, far from light, yet massive enough to hold onto thick blankets of atmosphere. Their surfaces shrouded in eternal night. These worlds, often called rogue or renegade planets, might number in the trillions. Some as small as Mars, others larger than Jupiter. They might have oceans of liquid methane or hidden seas beneath crusts of ice. Their sources of warmth are not sun rays but inner heat, left over from cosmic birth or fueled by radioactive decay. Beneath their surfaces, hydrothermal vents could bubble with chemical energy, a mimicry of the cradles that birthed life on Earth. A dark world, yet possibly not a dead one. Could we live there? A planet without a star means no solar energy, no seasons, no day and night. A civilization would need to burrow inward, deep below the crust, where geothermal heat lingers. Cities carved in stone, lit by artificial suns, powered by fusion or the slow burning of matter. Farms in cavernous biomes, oxygen trees under lamps, rivers of melted ice confined to tunnels. A whole world lived in interiors, never seeing a sky, never knowing a horizon. But such a world is also safe, from radiation, from flares, from asteroid impacts. A sanctuary for humanity if the galaxy turns out to be less welcoming than we hoped. Yet also a prison. A rogue planet, once entered, cannot be steered. No solar wind to ride, no gravitational well to slingshot from. It is a cosmic ghost ship, drifting through space toward nothing in particular. Light years pass, stars sweep silently by in the distance, but you never approach them. You don't orbit, you wander. To live on a renegade planet would be to accept a life without morning, without constellations, without the beauty of watching worlds dance around fires in the sky. Your children would grow up without knowing stars, without knowing time the way Earth taught it, without knowing stories that begin with when the sun rose. Some might call that freedom, others exile. And yet, there is a strange poetry in the idea. A people who leave the stars behind to live among the hidden spaces of the cosmos. A humanity that refuses extinction by building life in the void rather than orbiting light. A final act of defiance or humility. Not seeking brightness, but making our own where none is given. So what is the renegade planet? A home to run to, or a mirror showing us what we fear most. A world unbound, like us in our darkest possibilities, drifting, searching for meaning in the cold. Every launch from Earth is a battle against gravity's fierce embrace. To escape, we spend billions, risk lives, burn fuel faster than thought. The first mile is the hardest. Earth's gravity well is a silent tyrant, an invisible force holding us close, as though the planet refuses to let us go. Every rocket you've ever seen, every ship that's broken the sky, is built around one goal: defeating this ancient pull long enough to taste the vacuum beyond. The physics is deceptively simple. To leave Earth, you need to travel about 11 kilometers per second, over 25,000 miles per hour. anything less, and gravity hauls you back like an anchor. But achieving that speed isn't easy. It requires fuel, lots of it. And the cruel paradox of rocketry is this: the more fuel you carry to accelerate, the more fuel you need to carry that fuel. A rocket is a flying stack of explosive energy, 95% fuel, 5% payload. The ship is mostly the fire it needs to fly. Every launch is a carefully choreographed dance against annihilation. G-forces slam bodies into seats, engines roar hotter than the sun's surface. A slight imbalance in pressure, a misfired valve, and decades of engineering and human lives vanish in a blinding flash. For every success we celebrate, there are silent fields of wreckage and stories cut short. The cost of reaching the edge of space is paid in risk and sacrifice. And that's just to reach orbit. To go farther, beyond the moon, into deep space, or toward another star, the costs multiply beyond imagination. Push into the interstellar medium where fuel cannot be scooped, where nothing can slow you but the faint drag of atoms between stars. Every kilogram you lift from Earth is a debt. Every ounce of gear, food, water, shielding, all carries a price. We quickly discover there is no such thing as a cheap launch into infinity. Some dream of space elevators, tethers reaching from the ground to geostationary orbit, erasing the need for rockets entirely. Others imagine mass drivers, firing supplies from the moon like bullets into waiting ships. But for now, the reality is fire and thunder and fragile metal shells. Humanity leaves Earth in violent bursts, our technology still closer to artillery than to starships. And so, even before we dream of warp or wormholes or light sails, we face an ancient enemy: weight. It drags on our bodies, on our ambitions, on our dreams of flight. It reminds us that we are creatures born in the lowlands of a planet's gravity, not the slick, silent heart of space. Gravity is the first barrier. The oldest test. It asks the question no technology can avoid: how badly do you want to leave? The answer, so far, has been written in flame. Each decade brings new inventions, new promises of soon. Yet the stars do not move closer. Technology grows, but does it grow fast enough to break the universe's rules? It's easy to believe we're on the verge of breakthrough. Every year, headlines scream about revolutionary engines, fusion reactors, quantum drives. But behind every glossy announcement lies a quiet truth. Most of our advances are incremental, not transformational. Our devices shrink, but the distances stay the same. Our screens sharpen, but space remains silent. 100 years ago, we dreamed of jetpacks and moon cities. Today, we dream of Mars colonies and warp engines. The dreams have moved outward, but always just beyond reach. Progress is real, but it's also deceptive. A faster phone, a smarter AI, they give the illusion of acceleration. But compared to the raw physics of spaceflight, they are grains of sand on a beach. Propulsion hasn't leapt forward the way computation has. Nuclear fusion, the holy grail of energy, is always 2 decades away. Our achievements are like pebbles thrown into the ocean of cosmic time, ripples, not waves. The universe is governed by brutal constants. The speed of light doesn't change because we're impatient. The energy to accelerate mass remains immense, whether we're building a spacecraft or a slingshot. Space isn't simply big, it's indifferent. It doesn't bend to enthusiasm. And while humanity celebrates each leap in miniaturization or medicine, the stars remain impossibly still. But perhaps the greatest illusion we entertain is not about the universe, but about ourselves. We assume progress is inevitable, linear, exponential, that tomorrow will always be better than today, that every problem has a solution. But history tells us otherwise. Civilizations rise and collapse. Knowledge is lost. Ambitions turn inward. The ruins of the Library of Alexandria whisper a warning. As do the ghost cities of forgotten empires, progress is not a straight line. And even if progress does continue, we face another paradox. The faster we advance, the less we may need to go. Virtual worlds. Entire civilizations encoded into substrates of light. Why risk the void when we can simulate wonder? Maybe, then, the question isn't, can we reach the stars, but whether we will still want to when we're finally able. Will future humans even care about crossing the galaxy? Or will they have built universes of their own? Pocket reality is more vibrant and responsive than anything found in the cold arms of Andromeda. Progress can deceive. It seduces us into thinking speed is destiny. But the stars teach another lesson, that not every frontier is conquered through invention. Some are reached only through endurance, wisdom, or a fundamental shift in what we seek. Perhaps the true illusion isn't that we will reach the stars soon, but that we were ever meant to. What if interstellar travel is the barrier that ends every civilization? What if the stars are full of ruins, worlds that tried? It is a whispered dread, a cosmic riddle that asks, why do we see no other minds? No cities orbiting distant suns, no machines humming between galaxies, no voices across the void. If life can emerge on Earth, why not elsewhere? There are only two answers, and both are terrifying. The first, we are rare beyond belief, a cosmic accident, a fluke in the chemical soup of stardust, one intelligence among a trillion silent stones. The second, we are common, but so is extinction. Perhaps countless civilizations once gathered their will, built their engines, lit their sky with hope, and tried to leap into the interstellar ocean. Perhaps they reached the same precipice we now stand upon, the threshold of leaving home forever. And perhaps that leap, across time, across distance, across meaning, is the undoing of all who dare. Maybe the universe is littered with monuments to this failure, ruins of dead worlds where civilizations launched 1,000 ships and never returned, moons scarred by forgotten mining expeditions, wreckage of starfarers who underestimated radiation, loneliness, the tyranny of engineering. Cities turned to dust while their people slept in cold arcs, never waking. The Great Filter could be anything: nuclear war, ecological collapse, resource depletion, AI gone rogue, cosmic radiation, or simple apathy. But another kind of filter lurks ahead: the cost of leaving everything behind. The moment civilization must ask, is it worth it? When the energy needed outweighs the will to continue. When culture frays under the pressure of waiting centuries for a dream that might never arrive. Even if we survive every danger Earth throws at us, pestilence, war, famine, the universe still demands a price. It requires that we solve propulsion, resource management, biosphere replication, long-term psychology, and the ethical weight of multi-generational journeys. And if one of these systems fails, just one, the ship becomes a drifting tomb. Maybe no civilization has ever passed this trial. Maybe the silence in the sky is not a sign of peace, but warning. There's a chilling clarity to that idea, that our dreams of going to the stars might be not our triumph, but our test. And if we fail it, Earth may become just another fossil in the cosmic record. But there is another way to see the Great Filter, not as a wall, but as a truth carved in starlight. Only a species that can balance ambition with wisdom, power with care, survival with sacrifice, can ever hope to move beyond its cradle. Maybe we are being filtered, but maybe, with enough humility, we can be the first to pass through. Looking into the void, we imagine stories, futures, destinies. But maybe the void sees us back, wonders why we still burn our dreams in rockets so small, so fragile. The night sky is not just a backdrop, it is a mirror of our greatest ambitions and our deepest uncertainties. With every launch, every probe, every whispered signal flung across light years, we are not just exploring, we are confessing. We are saying, we are here. We long for more. We wonder if we belong. But what if the cosmos has already formed its judgment? Space is vast, ancient, and unyielding. For billions of years, it has watched stars ignite and die, Planets form and shatter, comets fall like silent rain. Against this backdrop, our rockets, flimsy scaffolds of aluminum and fire, are like paper boats pushed into a hurricane. Noble, yes, but small, and the void, if it had consciousness, might blink in confusion. Why do we reach outward when we're not yet whole within? Why do we fling our fragile forms into orbit while still fighting over soil and belief back home? Perhaps the silence of the universe is not indifference, but patience. It questions us, not through words, but through the cold vastness it offers. Who are you, travelers of carbon and water? What will you bring with you? Are you creators or conquerors? Will you plant seeds or fire? We like to believe that the universe is waiting for us, that it will open its doors if only we knock hard enough. But maybe the universe doesn't allow entry. Maybe it demands preparation, maturity, a sense of collective self, before we are trusted to cross the stars, not just with bodies, but with wisdom. Space does not stop us. It just asks harder questions the further we go. The more we peer into it, the more it reflects back our contradictions, our ingenuity shadowed by our destruction, our compassion tangled with our greed, our wonder tainted by our haste. For every telescope we build, we also build bombs. For every ship we launch, we fill another ocean with plastic. The darkness wonders, are you climbing toward the stars or running from the wreckage you made below? And yet, the same void that questions us also calls us. It beckons, not with promise, but with potential, not with comfort, but clarity. Perhaps we are meant to be humbled by its scale, to be reminded that whatever we become among the stars, we must be better than we were under them. Until then, every launch is a message, not just to the universe, but to ourselves. We're still trying, still learning. And the darkness, for all its mystery, still listens, still waits. Every star in the night sky is a monument to time. They don't rush, they burn for billions of years. In their patience, perhaps they mock us or warn us. Stars do not hurry. They are born in the slow collapse of clouds. They shine in steady fusion. They die in silence or spectacle, their remnants seeding the next generation of fire. Their lives span epochs we can scarcely imagine, whole lineages of creatures rising and falling on planets orbiting their glow. And yet, as humans, we measure our existence in decades, centuries if we're lucky. We demand immediate answers from a universe still composing its questions. When we dream of interstellar travel, we often measure our goals in years, 50 years to Alpha Centauri, 100 years to another world. But stars laugh at such urgency. They tell us that time is not a barrier, it is a fabric, a rhythm. We are the ones who are trying to sprint across an ocean meant to be sailed. They burn, unbothered by our clocks. Their fusion furnaces care nothing for our ambitions. The very speed of light, that cosmic speed limit we curse, is also a gift, ensuring the structures of galaxies, the flow of matter, the continuity of life. Too fast, and everything collapses. Too slow, and nothing happens. Perhaps then, patience is not the universe denying us. It is the universe shaping us. The stars might be saying, grow first, learn your own rhythms, earn the right to leave. They watched Earth coalesce, they watched its seas form, they watched its first bacteria bloom and snuff out and bloom again. They waited as forests rose, as ice ages fell, as minds awakened. And now, as we look toward them with trembling aspiration, they are still waiting. Not for our rockets or our calculations, but for our understanding. The stars do not mock us. They clarify us. They hold up the truth that for all our speed and invention, we are still in cosmic childhood. Our species is barely 300,000 years old, a snap of sparks in the void. The stars have been our silent tutors all this time, teaching by example, endurance, equilibrium, gravity balanced by light. And maybe, if we listen, really listen, we will realize that the race to the stars is not a sprint, but a pilgrimage, one that rewards those who build lasting foundations, not just quick exits. To reach them, we may need to stop fighting time and learn to work with it, not demanding shortcuts, but innovating in cycles. Not forcing progress, but tending it as we would a fire meant to last through the night. The universe is ancient, but not inaccessible. We just need to recalibrate our sense of scale, let go of timelines we invented, and accept the ones already written in the starlight. Someday, we will stand under another sun, not as conquerors, but as graduates, not as orphans fleeing chaos, but as kin returning to a family we finally understand. Until then, every night sky is a reminder. The stars are not far. We are simply young. No one has crossed interstellar space with intent. If we try, we will become the first. And the first things in history are always part miracle, part tragedy. To be first is to venture into a landscape with no maps, no storytellers who've returned, no footprints in cosmic dust to follow. It's to step into the unknown knowing that you may rewrite history or vanish inside of it. Our ancestors were first once too. The first primates to descend from trees, the first humans to cross oceans in boats that seemed far too fragile, the first astronauts to break the boundary of atmosphere and look back at Earth as a whole. Each first changed everything, not just technology, but identity. But for every first that succeeded, dozens failed. Ships sank, climbers fell, machines exploded, the unknown exacts a toll. To cross the stars means staking everything: wealth, knowledge, courage, the lives of those willing to leave everything behind. And for what? Glory? Science? Survival? The more profound truth is this: being first is not about arriving, it's about deciding that arrival is worth dying for. But there's a loneliness in being first too. The first creature to crawl onto land never knew if more would follow. The first human to orbit Earth didn't know if anyone would come after. The first interstellar travelers, should they leave, will not know if humanity remains behind them or evolves into something entirely different. Will they be pioneers of a new age or ghosts of a forgotten one? And yet, history whispers encouragement. The first always carry the heaviest load, but they also open the path. Sacrifice is their legacy. They become myths, so others can become citizens of new worlds. The miracle of firsts is not the journey, it's the inheritance left in their wake. So perhaps, someday, our thin metal ships will push beyond Oort clouds into the black river that lies between suns. The first breaths they exhale into alien night will be a declaration that curiosity outweighed fear, that the species who built pyramids, wrote symphonies, split atoms, and dreamed in mathematics did not choose the cage of familiarity over the horizon of possibility. We will be first, but not alone. We will carry Earth in our cells, our stories, our silence, and even if no one ever follows, even if we never return, the syllable of our journey will echo across time. Humans were here. They dared. They mattered. Suppose we make it. We land. We breathe alien air. Then what? Who do we tell? Who do we share it with, centuries after the world we left has forgotten our names? In our stories, triumph is always followed by applause, cheers, celebration, banners waving in sunlight. But interstellar triumph would be quiet. There would be no voices at mission control, no news headlines, no homecoming parade. The first footstep on alien soil might be heard only by the wind. Picture the scene. A ship arrives after 150 years, 300 years, maybe longer. Generations have lived and died en route. Knowing only recycled air, metal corridors, and simulated oceans in dreaming rooms. They've studied a world they've never touched, rehearsed how to walk under a sky they've never seen. They exit the airlock, touch the dust of another planet, and look up at a sky full of unfamiliar stars. And there's no one left who remembers why they came. The people waiting for news are gone. Nations have changed, languages evolved, cultures forgotten. Humanity has moved on, or collapsed, or transformed beyond recognition. The video message you send back to Earth might not even be decodable. You might as well be whispering into a canyon. Triumph, real triumph, isn't glory, it's responsibility. To establish a foothold on an alien world, to build shelter before storms, to plant crops in strange soil, to write the first books in a new world, and to do it all without knowing who you are in the eyes of anyone but yourselves. Your mission isn't just to survive, but to give meaning to survival. There is a deep, haunting beauty in that silence. Because in the absence of applause, triumph becomes something purer, a conversation between your ancestors and your descendants, between the ghosts who left Earth and the children who will never see it. A reminder that greatness often comes without witnesses, that the most important victories are sometimes barely seen at all. And perhaps that is the point. We don't cross the stars to become legends. We do it because someone must. Because meaning isn't something we carry with us. It's something we create when the universe gives us nothing else. In that silence, there is triumph. In that isolation, there is purpose. In that lonely step onto alien ground, there is the final truth of exploration. We are storytellers. And even if our story is told to no one but the stars themselves, it will still have been worth telling. Interstellar travel isn't just a journey through space, but through the deepest truths of existence. That we are fragile, that time is cruel, that longing isn't always answered. We dream of the stars as if they're a destiny, but the truth is that they are a test. They reveal who we really are, not in the glow of achievement, but in the cold silence between attempts. Even the idea of crossing the void forces us to face our own smallness. Our ships are not grand arcs, they're tin cans launched into eternity, a tiny spark of life wrapped in metal, fighting against a darkness older than time. Everything inside them, our food, our air, our laughter, our histories, is counterfeit Earth, or worse, a reminder of what we left behind. We are not made for space. Our bones weaken, our cells decay, our minds crave horizon, storm, shadow, seasons. Even our language collapses. Words like day and sky and home become less real with every passing year aboard a starship. The longer we travel, the less we remain human in the ways that matter. Time adds its own cruelty. A journey that begins with bravery may end with bewilderment. Generations born mid-voyage might resent the mission they never chose. Those who reach a distant sun will never meet the ones who launched them. The universe demands a patience beyond biology, a patience only myth has ever hinted at. And perhaps the most devastating truth is this: longing is not always answered. We might search for life and find none, reach for a new world and see only barren landscapes, call out to the stars and hear nothing in reply, not even our own echo. Yet tucked inside that truth is another. Meaning is not found in the outcome, but in the attempt. Fragility does not cancel purpose. Time's cruelty does not erase beauty. And unanswered longing, the very ache of reaching, may be what makes us most alive. Interstellar travel unmasks the romantic illusions we cling to, not to punish us, but to remind us. That wonder is often paired with sorrow. That effort is no less noble for its uncertainty. That mortality is not a flaw, but a frame around the masterpiece of our choices. We cannot escape these truths, but maybe we don't have to. Maybe the stars are not salvation, but surrender. Not places to flee, but mirrors to see ourselves clearly. Through them, we discover not eternity, but integrity. That we dared, that we tried, that even at the edge of the impossible, we still carried hope like a lantern in the dark. Perhaps the future is full of explorers who never return, whose stories exist not in history books, but in the silence between galaxies. We like to imagine that every journey ends with a homecoming, a story retold beside a fire, a monument erected in honor of the brave. But space does not promise closure. It accepts footsteps without leaving traces. It swallows monuments whole. It takes the names of those who cross its borders and scatters them like stardust. The first interstellar explorers may never return to Earth, not because they failed, but because the universe itself has no concept of return. They may settle on distant planets or drift forever in the void. Their signals, sent back through the slow medium of time and light, might arrive long after Earth has changed, broken, forgotten. Their children may grow up beneath unfamiliar stars, never knowing blue sky or ocean tide or the weight of gravity. Their culture may evolve so distant from ours that Earth becomes a legend, one that even they can't quite believe. They will not be here to receive applause. They will not hear their names read in halls of fame or etched in monuments. Their descendants may leave no trace we can find, not even fossils in alien soil. The greatest journeys in human history may go unrecorded, like a poem whispered once and lost to the wind. But is that failure or freedom? There's a strange beauty in the idea that not all stories are for the world. Some are only for the people who lived them, for the hearts that beat through the cold, for the hands that planted the first seeds on another world, for the tears shed under an unfamiliar sky. Legacy doesn't always mean a statue. Sometimes it's just the quiet knowledge that something unimaginable was done, even if unknown. Perhaps the universe is already filled with footprints we'll never see, civilizations that lived, dreamed, traveled, and vanished into their own horizons. Not because they were defeated, but because they accepted that the journey was enough. In a cosmos where even stars burn out, maybe the only true measure of worth isn't who remembers, but who dared. Who went, who stared into infinity and said, "Let me be the one who walks here." If our explorers disappear into the dark, leaving no mark behind, it will not mean they failed. It will mean they honored the oldest truth of discovery, that the world is made larger by every step beyond its borders, even if no one is there to watch. Whether we reach the stars or not, the very act of dreaming changes us. In our longing for other suns, we learn what it means to be from this one. Interstellar travel is more than a technical ambition. It's a spiritual excavation. When we look up and see not just dots of light, but possible futures, the universe becomes a mirror of our own curiosity, our own restlessness. The stars do not change, but we do, simply by thinking of them. To imagine stepping onto another world is to imagine ourselves in new shapes. It forces us to reckon with everything we take for granted: air, water, trees, language, gravity, history. The sky above our heads becomes a ceiling we ache to pierce, not to abandon Earth, but to understand it more deeply. For in thinking about what lies beyond, we remember what lies within. Every child who has ever traced constellations or marveled at rocket launches is participating in this transformation. Every diagram of a wormhole, every artist's rendering of a distant planet, every story whispered about a starship is a gentle widening of human perspective. We are stretched by our own imagination, pulled beyond the edge of comfort, asked to contemplate the scale of creation and our small, luminous place within it. Even if we never reach Proxima Centauri, or settle the moons of exoplanets, or surf the currents of interstellar medium, the yearning itself elevates us. It forces collaboration across nations, languages, generations. It drives us to protect this planet so we can learn enough to leave it, and perhaps love it enough to stay. The journey outward always becomes a journey inward. Perhaps this is the secret the stars have been holding all along, that they were never goals, but guides. That in trying to touch them, we discover what makes us human. Our insistence on trying the impossible, our refusal to settle for the known, our capacity for awe. Whether we cross the void or not, the stars have already changed us. They have called us upward, pulled at our neurons, shaped our stories, humbled our days, and in seeking new worlds, we may finally understand what it means to be custodians of this one, to hold a fragile, blue miracle in the dark, and to know, at last, that it is precious not because it's the only place we can live, but because it's the only place we've learned how to give. We have walked slowly from the first humbling fact, the immensity between stars, to the hard truths that sit inside our brightest dreams. We learned that speed has limits, that distance is a kind of time, and that every advance in engine or idea carries a bill we will have to pay: energy, years, biology, purpose. We held in our minds the tiny, lethal grains of cosmic dust, the loneliness of generations born aboard twisting metal, and the possibility that the first true travelers might not be human at all but quiet, tireless machines. We considered the grief of leaving, the strange arithmetic of time dilation, and the hope that some far-off water world might, in its own way, be kinder than we imagined. There is devastation in these facts, yes, the loss of immediacy, the knowledge that many voyages will only end in stories or decay. But alongside that devastation lives a gentler truth. Dreaming changes us. To plan, to calculate, to sing to the dark about what might be, this work reshapes our ethics, our technology, and the way we value home. Even if no ship ever reaches the nearest light within a human lifetime, the act of trying teaches us to care more deeply for the single pale world that taught us how to count the stars. Tonight, let that awareness settle like a soft cloak. Breathe slowly and feel gratitude for the gravity that keeps your feet familiar, for the atmosphere that hums with life, for the smallness that makes human touch so precious. If the stars are distant, they are also patient. They will wait. For now, rest in the knowledge that you belong to a planet that sustained life long enough to ask these questions, to invent these dreams, and to hold them gently in the dark. Let your thoughts become quiet. Let the steady, slow heartbeat of the cosmos lull you. When you wake, you will carry this strange mercy with you, that we are fragile, brilliant, and, for reasons both scientific and sacred, worth protecting. Good night.